Hello, viewers. This is Chetan again from Stiblop Academy and Consultancy. Welcome to yet another subsequent session of the product development process. So, today's session is on the feasibility study. So, let's start. What is the feasibility study? Join with me. What is feasibility study? A feasibility study is an activity to find the possibility of making an idea or a concept workable to perform a required function. Let's see what are the learning objectives in today's session. I will just walk you through the product design and development process, followed by idea generation process and feasibility study. Yeah, so this is the product design and development process, which I was speaking right from the first session. The product design and development process is having 8 stages. The first stage is the decision to take the new product development, followed by feasibility phase, concept phase, preliminary design and development phase, detailed development phase, final development phase, production phase, and the end phase. We have already seen the first step, that is a pre-study. Okay. The next step that comes in the feasibility phase is the ideas generation phase. In this step, we along with our team do the brainstorming and generate n number of ideas. Once the ideas are generated, we do the feasibility study on those ideas. The output of the feasibility study comes as the selection of one or two ideas which are subjected to the concept design and development. Okay. So, whatever the concept we develop, we do the further feasibility study on those concepts at a more detailed level. And once we are done with this, the result is subjected to the concept analysis and review to the cross functional team or the internal stakeholders, which I was speaking before. So, with the help of the cross functional team, we select one concept and freeze it, which is subjected to preliminary design and development. So, once the preliminary design and development is finished, it is subjected to the virtual analysis. The virtual analysis includes the design verification and the DFMEA. Okay. So, once we get the result of this virtual analysis, we carry out the design modifications based on that, and that is called as a detailed design and development. And once the detailed design and development is finished, we submit the output to the proto build and testing. And once we get the result of the proto testing, we do the design modifications as per the proto update and followed by the creation of the drawings and the documentation. Okay. So once the drawings are created, we submit those drawings and the documentations to our manufacturer. The manufacturer does the manufacturing feasibility and he asks us to do the further design update as for the manufacturing check. Okay. And parallelly, he carries out the manufacturing of the design. He directly doesn't jumps into the manufacturing. He buys the raw material. He starts casting off the blocks which is required for the tool design. And once the tool is ready, he comes out with the first out of tool parts and he does the assembly trials and based on the assembly trials he does the tool update and all this feedback he gives us that this is the changes that we have to do on our design, and based upon his feedback we create the change request in our internal system, and based on the change result we further modify our design. That is called as the final design and development. Once the final design and development is completed, we submit the output to the production build or the product build. So in the product build, whatever the items that have come out of the tool, we take those quantities and we build the actual product. So this is not the final product. Still, there is a lot of testing involved in this. So based upon that product build, we do the product validation. And whatever the results that we get out of the product validation, that feedback is taken as an input for the final product update and release. And once the final design modifications is carried out, We submit that to the batch and the series production, followed by the production trials and the product launch. Okay, so this is all about the product design and development process. You might wonder why I have given the different colors. The gray color shows that the maturity of the product is very, very minimal, followed by the yellow color, followed by the gold color, light green, and finally the dark green, where the product is ready to get launched in the market. The output of the feasibility study is the feasibility report, which goes as a deliverable to the next phase. Moving on to the idea generation process. Before we start this, let's try to understand what the idea is and what some of our great people said about this. First, let's see what our ex-president of India, Dr. APG Abdul Kalam, has told about the idea. He says that an idea is a curious thought expressed either in the form of a sketch or a narration leading towards creativity. And what Earl Nightingale has said, everything begins with an idea. Okay. What are the steps involved in the idea generation process? The first step is the input study. So, in the input study, first of all, we derive the functional requirements from the product backlog. I hope you remember the product backlog in the pre study. The first functional requirement is to temporarily receive the fruits and cut down the speed. The second one is to separate the fruits as per the QTM instructions, whether it is okay or not okay. And the third one is to collect them in a two separate bins. Okay. And the next step in the input study is to choose that product from the players list which is close to the functionality of our machine. The next one is to do the functional analysis of the overall machine and benchmark to generate the ideas. Now let's try to understand which is that product which we have taken to benchmark. So it's nothing but the sand filtering machine. The sand filtering machine is manufactured by Sri Murugappa Engineering Works in Coimbatore. Okay, so this is a sand filtering machine that is having a vessel diameter of 200 meter cubed, vessel height of 800 mm, capacity of 3000 meter cubed. Let's try to understand what are the different functions that are involved in the sand filtering machine. The first function is the input feeder. The second function is the rotating mesh. The third function is the disposal system, which disposes the filtered out granules to the outside. So what happens here? The sand, the coarse sand is fed in the input system, which is further transferred to the rotating mesh that is driven by the motor. So this rotating mesh works on the principle of the centrifugal force, which throws away the lighter materials and collects the heavier materials at the center. So the lighter materials comes out as fine sand, whereas the heavier material goes out as the granules. Okay, let's see what is the input for the second step. Here we have the input as the QTM machine, which is the rough sketch which I have drawn here, and the primary idea that is generated to, to fulfill the first functional requirement is a net kind of thing which receives the fruits and cuts down the speed of those fruits. Okay, yeah. What we generally do in the step 2 is we assemble with our team and we do the brainstorming. Why do we do the brainstorming? To generate a number of ideas. So now what are the ideas to be generated? We have to come up with the mechanisms that can separate these fruits based upon the QTM instructions, and we have to collect them in two different bins. Okay. The next one is the categorization of the ideas. Why do we do the categorization? The categorization allows us to combine those ideas which are having the similar function and mechanisms. Okay, now moving on to the step 3, that is a brainstorming session of the idea generating process. So here What we have done is the brainstorming of only the mechanical ideas. Okay, I'm not doing the brainstorming of any electrical or the electronic ideas, which includes artificial intelligence. Okay, the first idea that got generated is the rotating pan setup. So, in this rotating pan, we have a hemispherical pan kind of thing which is welded to a rod that is driven by the gear set. Now, if the falling fruit is okay, the rotating pan receives that fruit and rotates in the clockwise direction. And if it is not okay, it rotates in the anti-clockwise direction. But here there is another problem. The falling fruit doesn't fall vertically down. So for that, we have to come up with another mechanism which can collect this fruit in the falling in the right direction. Okay. The second set of idea is the channel and gate. So in this, we have a channel kind of mechanism along with the gate which is inclined at certain angle below the net. So the falling fruit falls on the vertical channel here. And before it reaches the gate, it gets the signal from the QTM as OK. Then the gate rotates in the anti-clockwise direction and allows the fruit to go in the OK channel, and it gets collected in one bin. And if the fruit is not OK, the gates the gate get rotated in the clockwise direction and the fruit flows through the channel which is not OK. The third idea is the hole and the slider. In this setup, we have a fixed bowl kind of thing with a pass through, accompanied by a moving slider with a hole in between. If the fruit is not okay, then the slider comes with a hole aligned with this pass through, and the falling fruit that is not okay slips through both the holes and gets rejected. If the fruit is okay, what happens is that the slider moves a little bit forward so that the hole is misaligned with this pass through, and the fruit gets slipped and slides onto another bin. So, moving on to the next step, which is on the feasibility study. So, in the feasibility study, we check which is that idea that can be made possible to work as per our functional requirement. Okay, so we form a table like this. So, this table is having several columns. The first column, we have the ideas listed. In the second column, we have the images. In the third column, we have the categorization of these ideas. And we have several other columns where we have the evaluating parameters, where each idea can be evaluated against each parameter. Okay, now let's see one by one. The first idea is the rotating pan. This idea is categorized under the driving group because this is having two set of gears. Okay, and as far as the simplicity is concerned, this is moderately simple, and you can see the rating that I have put over here. And as far as the cost is concerned, the cost rating goes a little bit less. See, if the idea is simple, then the cost rating goes high. If the idea is complicated, then the cost rating goes low. Okay. Next, coming to the feature. So it is quite obvious that we can add lot number of features to this particular idea. Now coming to the workability, this can be workable. No doubt about that. Coming to the reliability and the durability, since this is having the gear set, it is more reliable as compared to the other ideas. Now coming to the functionality column, so the functionality here is a product of the workability and the reliability. Okay, so the total score that comes out here is 11. Moving on to the second idea. So this is categorized under the combination category because this is the combination of oscillating mechanism and the gear and gear set mechanism. Okay. As far as the simplicity is concerned, this is more simple compared to the first idea because this is having only one set of mechanism and a thorough divider which divides the good fruits and the not good fruits. Okay. Now coming to the cost, since this is more simple, the cost rating is also high. Featured, of course, this also can be featured. Workability, yes. Reliability and durability. This is less reliable and durable as compared to the first idea. The reason because this is not a gear set and the gear set is more durable. Another reason is the dust could be collected between the gate and the channel, because of which we need more maintenance. So this is less reliable. As far as the functionality is concerned, the this is a product of the workability, reliability, and durability. So we are having good score here. Now coming to the third idea, which is the hole and the slider. This comes under the category of 4-bar linkage. Of course, this is complex because we have the 4-bar linkage mechanism, which is complicated compared to the gear mechanism. And coming to the features, of course, this has the features. And coming to the workability, this is less workable because sometimes what happens is that 4-bar linkage mechanism may get stuck up because of one or the other reasons. And coming to the reliability and the durability, this is less durable. So the functionality score goes down for this, and the total score for this comes to 9. So this is the way how we do the feasibility study of all the ideas and filter these ideas to lesser number of ideas which can be generated as a concepts. So the ideas that get selected here to generate the concepts are channel gate and the rotating pan. So I hope you have followed everything until now. And if you have any questions, please put them down in the comments. Okay. Thank you, viewers. So my next session will be on the concept design and development. Thank you.